Welcome to Study Loop.
This question, we have very unstable isotope of potassium, that is 40 K. And this unstable isotope has a half-life of 1.28 times 10 to the 9th here. We can use the amount of potassium in the rock to date when this rock first came into existence. Part A asks us how many decay occur in a sample that contains the original mass 1.63 times 10 to the negative 6 grams of this potassium. So this can be found. We're looking for how many decays occur per second. So we have an equation of dN dt equals lambda times n. So this equation is that the amount of change of potassium is proportional to the amount of potassium in the sample by this number lambda. So we do not know what lambda is, but since we know the half-life, we can find lambda from the half-life. Okay, so lambda equals 0.693 over half-life. This is given the equation 43.16 of this chapter. So this is 0.693. As a half-life is 1.28 times twice here, we need to convert it to seconds. And 1 year is 3.156 times 10 to the 7th second. So the constant lambda turns out to 0.715 times 10 to the negative 17. Once we know that, we can use this equation to calculate the amount of dN dt. But one more thing is that we also want to know how much, what is the number of potassium, because here we use N instead of mass. So we also need to find how many potassium are there inside the sample. So N equals the amount of mass in total over the mass potassium is 40 U, and each U is 1.66 times 10 to the negative 27 kilogram U, because we know it's 40. So the amount of potassium atom is 2.454 times 10 to the 16. All right, we have everything we need, and we can calculate dN dt. dN dt equals lambda times n equals 1.715 times 10 to the negative 17 per second times 2.454 times 10 to the 16 equals 0.421. There is no per second, so that is say we have 0.42 decays happening per second. So all of this is part A. Part B is a unit conversion. We ask what is this amount of activity in terms of curies. So this is a unit conversion, and if we remember, 1 curie is 3.7 times 10 to the 10th decay. So curie equals 3.7 times 10 to the 10th decay per second. So we're just taking a ratio. We had 1.715 times 10 to the negative 15 per second, and then we divided by 3.7 times 10 to the 10th per second. So this gives us 1.14 times 10 to the negative 11. So the result is 1.14 times negative 11 curie.